Here we are on section 3.8, video number 2, and we will pick up right where we left off. Example number 6. We have the secant of theta is equal to the cosine of theta. Now, basically, we need to somehow get these into the same one. Luckily, secant is the reciprocal of cosine, so we can rewrite this as 1 over cosine of theta equals cosine of theta. And then we can subtract both sides by cosine of theta. Which will equal 0. And then common denominator will give us 1 minus cosine squared of theta equal to 0. And the only place that this expression here will equal 0 is when the numerator equals 0. So we get 1 minus cosine squared of theta has to equal 0. Subtract 1 from both sides. Divide both sides by -1. And then take the square root of both sides so that the cosine of theta is equal either to a +1 or a -1. And then we come here and say, okay, cosine, since it's either positive or negative, means all 4 quadrants. And here's a special case. These are quadrantal angles because the cosine is +1 or -1. So cosine of theta only equals +1 here and equals -1 here. So the only two answers we should be able to get out of this would be 0 and pi, which are the appropriate names for this angle here and that angle there. Example number 7. The sine of 2 theta minus the sine of 4 theta equals 0. Now here we need to be very careful. We've got sine and sine. The problem is they aren't of the same angle. So without doing anything, it doesn't really make us, or there's no way to combine those until we get the same angle as well. And so what I'm going to suggest we might do here first off is, okay, sine of 2 theta can be written as 2 times the sine of theta cosine of theta. The sine of 4 theta, using the double angle formula, will be 2 the sine of 2 theta cosine of 2 theta, and that still will all equal 0. Well, we can now split this up, the sine of 2 theta and the cosine of 2 theta, and we can use the double angle formulas there. So this will become 2 sine of theta cosine of theta minus 2 times, okay, the sine of 2 theta is 2 sine theta cosine theta, and cosine of 2 theta, I'm going to use the cosine version of it. And all of that will equal 0. Well, taking this expression here and distributing it to this, we get 2 sine theta cosine theta minus 8 sine theta cosine cubed theta minus 4 sine theta cosine theta, still all equals 0. Now we can actually combine like terms because we have this here and this here, so it becomes -2 sine of theta cosine of theta minus 8 sine of theta cosine cubed of theta equals 0. Now I'm going to factor out what I can. Well, here I can factor out, whoops, I messed up here. I need, this is a plus because the minus a negative. Minus and minus becomes a positive. So this would become positive 6 instead of a 2. Okay. Now I can factor out 2 sine of theta cosine of theta, which will leave 3 minus 4 cosine squared of theta equals 0. And so that means either this equals 0, this equals 0, or this equals 0. And so I just need to set each one of those equal to 0 and go from there. So sine of theta equals 0, cosine of theta equals 0, or 3 minus 4 cosine squared of theta equals 0. Well, sine of theta equals 0 only occurs here and here. So in other words, theta is going to occur either at 0 or at pi. Where cosine of theta equals 0 will be there or there. So theta might equal pi over 2 or 3 pi over 2. Then finally here we need to subtract 3. And divide by negative 4. Continuing with the same problem, take the square root of both sides so that the cosine of theta equals plus or minus the square root of 3/4, which equals plus or minus the square root of 3 over 2. And so, since we're talking cosine, a negative and a positive cosine, it's going to be both, or in all 4 quadrants, and specifically what is the reference angle when the cosine is equal to the square root of 3 over 2. That would be at pi over 6. And so then we just have to name each and every one of these angles appropriately. This first angle will be pi over 6. That angle right there would be 5 pi over 6. The next angle would be 7 pi over 6. And the fourth and final angle would be 11 pi over 6. And so the final answer is 0, pi over 6, pi over 2, 5 pi over 6, pi, 7 pi over 6, 3 pi over 2, and 11 pi over 6, putting them in numerical order. Number 8. The cosecant of 3 theta is equal to 0. And I look at this and ask, okay, where does cosecant equal 0? It doesn't. Remember that the range for cosecant is positive 1 and bigger, or negative 1 and lower. So there's no solution here, so as soon as we've determined that, we can go on. Example number 9. Cosine of 2 theta equals root 2 minus the cosine of 2 theta. Now here we actually luck out because the cosines are exactly the same. Cosine of 2 theta, cosine of 2 theta. So we can go on from here. So what I'm going to do is I'm going to add cosine of 2 theta to both sides. So I get 2 cosine of 2 theta equals root 2. Divide both sides by 2. The cosine of 2 theta equals root 2 over 2. Now here I'm only dealing with positive, so cosine can only be positive in quadrant 1 and quadrant 4. But I also have to realize I have to go around twice so that I get all of the answers that are possible here. So my reference angle, where does cosine equal root 2 over 2? That's at pi over 4. So I would name this angle, or in other words, 2 theta would equal pi over 4. Or 2 theta would equal the angle going all the way around here, which is 7 pi over 4. Or 2 theta going my second time around, all the way around and then ending there, is 9 pi over 4. And finally, going almost all the way around twice will give 15 pi over 4. And then all I have to do is divide by 2 all the way through here. So theta might equal pi over 8. It might equal 7 pi over 8, 9 pi over 8, or finally 15 pi over 8. And once again, each of those fall within the range 0 and 2 pi. Example number 10. Cosine of theta minus sine of theta equals 0. Now here is the one time when, regardless of how hard you try, you cannot change a cosine into sine. You can't change a sine into cosine. We don't have any double angles. We don't have any half angles, stuff like that. So here we actually have to just go through the process. Algebraically, what we would do is we would add sine of theta to both sides so that we get cosine of theta equals sine of theta. And then we just have to think this one through, just brutally force it out. Now we ask ourselves, where does cosine and sine, where can they equal each other? Well, obviously it can happen in quadrant 1, but then the question becomes, can it be anywhere else? Quadrant 2, sine is positive, cosine's negative, so it doesn't work there. What about down here? Well, they're both negative, so yes, it could occur down here. What about here? No, cosine's positive, but sine is negative. So in this case, we have our 2. But then the question becomes, where does the cosine actually equal the sine? Well, reference angle happens to be pi over 4. Therefore, this angle would be pi over 4 as well. So theta, in this case, would either be pi over 4, or it might be 5 pi over 4.